Hey everyone, what's going on? Welcome to this talk on managing complex cloud deployments by using advanced ARM template features. That's quite a mouthful. What we will be doing is hopefully to show you some advanced and useful features using ARM. I'm Chris Noring, I'm a cloud advocate, and with me I got Angel Perez. Now take it away, Angel.
Hi everyone, welcome to Microsoft Ignite 2021. This is a Learn Live session where we're going to go over one of our Learn modules for you guys. I'm joining from Washington, Chris is joining from the UK. We're scattered all over, but we're very excited to be here to present to you guys during these rough times. Wishing good health to everyone and hope your families are doing okay as well. Please drop in the chat where you're joining us from. I see we got a couple folks from Australia, a couple folks from Denmark. We're going to be paying attention to the chat a lot throughout this, so a lot of engagement is what I'm looking for from you folks. So as I mentioned, we're going to be covering one of our advanced Learn modules in the ARM template learning path, and we're going to be covering all the exercise that we do in that module. You can find this at ak.ms/LRN251. To kind of, before we get started, talk a little about what is Learn. So Microsoft Learn is actually a platform that allows our customers to work through very segmented and broken down topics across a variety of programming languages and different practices. And what's very cool about this is that it provides you with sandbox environments. And in our case, we're going to be dealing with an Azure sandbox, which is great because you don't have to use your Azure credits to learn all these cool concepts that we're going to talk about today. So before we dive in, Chris, can you talk us through what prerequisites we're dealing with today?
Of course, thank you, Angel. When it comes to the prereqs, it's good if you're familiar with Azure. And when we say familiar, we mean that you know what the portal is, that you maybe know what a resource group is, and similar concepts. You know, pretty much you have done a few clicks on the portal already, you've seen a few things. We also think you will get the most out of this presentation if you know some basic ARM, meaning that it's good if you have tried to build and run your own ARM templates. But don't worry, Angel will be showing us some basic ARM. So if you're completely new to ARM, you will definitely get a minute or two on ARM. Visual Studio Code, that is an editor that we recommend. Why we do that is because it's really great tool for authoring, because you have extensions that will help you to author ARM templates, snippets, autocomplete, and whatnot. As part of one of our exercises today, we will be using SSH to connect towards a virtual machine. So if you're on Windows, make sure you have something like OpenSSH client installed. If you're on Linux and Mac, I believe you already have that support. Lastly, the Azure CLI or PowerShell with the AZ module are both good options for carrying out these exercises. There is not much of a difference between the two. Just choose what makes sense to you. So over to you, Angel. What will our audience learn today?
Awesome. So we're going to learn a couple things. First off, we're going to learn that in ARM, order matters. So what do we mean by that is how do we control what gets deployed first and what goes after and so on. Later, we're going to learn a little bit about how to manage secrets. It's ever more important for us to be secure when deploying applications, not just locally, but to the cloud as well. So we're going to learn about how to use Azure Key Vault to manage the secrets that we use for these applications. Later, we're going to learn a little bit about conditionally deploying resources. So by conditionally, we mean if something happens, deploy this resource. Simple as that. And lastly, but not least, we're going to learn how to clean up. So one of our goals, as we're always developing software for applications as well as for infrastructure, is to eliminate redundancy. So we're going to learn how to use something called the copy construct to actually eliminate the amount of code, reduce the amount of code that we actually write, and make good reuse of all of these things. But this session is live and interactive, so please say hi, ask questions in the chat. We're going to be, we have a lot of subject matter experts in the chat, so please don't be shy. Ask any and all questions, and Chris and I will do our best to get to these. So Chris, is there another ask you have for our customers today and try and get that engagement up and making sure they're not shy about asking questions?
Oh yeah, thanks, Angel. Please tell us where you're from. We're super interested to know where you're phoning in from. So definitely we want some engagement in this chat. Don't be shy in asking your questions. Tell us about everything, every kind of ARM problem you have. As Angel was mentioning, we got the entire Learn team and some really great experts, high and low, about this Learn module, not about it. Doesn't matter. Just keep those questions coming. Back to you, Angel.
Awesome. Thanks for reiterating the where you're from. I see we got some more folks from Serbia. We got a couple folks from Canada. So it's great to see we're getting presence from customers all over the world. So before we dive in any deeper, what is ARM? And I'm definitely not talking about, the arm that we have attached to our body. So ARM stands for Azure Resource Manager, first of all. And it's the central management layer that brokers all of the API calls between our Azure clients and the Azure services that we refer to internally as RPs. So RPs just stands for resource provider. Right now, you can deploy to Azure using PowerShell, using the CLI, using the portal, as many of you might have done so already, or using REST itself. At the end of the day, all of these end up sending a request to this central management layer that we call ARM. In turn, this central management layer then takes that request, it takes care of organizing everything and sending it to the resource provider. So for example, if you want to create a VM, you send that request through ARM to a PowerShell commandlet, for example, or maybe just through the create experience in the portal. And ARM takes care of sending the compute resource provider that request, and then in turn compute says, okay, let me see what I have. You're asking for a virtual machine that runs Linux, and it goes ahead and does all that. But today we're going to focus on ARM templates, and ARM templates is Azure's native infrastructure as code solution. So we're going to really be focusing on not just the benefits of infrastructure as code, what is infrastructure as code, but the benefits of infrastructure as code that is native on Azure as well. So before kind of giving it all away, why should we use it? Why should I care? And convince me that I actually need to use ARM. Chris, can you help me with that?
For sure. There are many reasons why you should be using ARM. One of them is the fact that you're able to store your infrastructure in text files, which means that you have an idea of knowing what you've actually put in the cloud. It's not the same thing as maybe using a state file. That's another version of using IAC, but you can definitely have an idea of what you've done to it. And that means that you can involve that text file in CI/CD processes, which also means that you can have automatic deployment. So anyone in your team essentially could be deploying. And anything you see on Azure resource-wise, I believe is supported by ARM because it's a first-class citizen. So that's really good to know as well. That's what we cover in day 0 support. One thing I wanted to kind of know more about, maybe you can tell me, Angel. There's this notion of failing fast and using pre-flight. Can you tell us why that's such a killer feature?
Definitely. So when we mean fail faster, it's not just fail fast in the sense of break something and figure it out, but fail fast with some validation, some guidance as to how to get to a working state. And internally, we have something called the pre-flight API. It's actually our validation API. And what it does is this pre-flight API sits before the deployment API. So whenever you're deploying via an ARM template, what happens is that deployment, the subset of all of the different resource providers. So let's say you have a couple of VMs. All of those VMs that fall under the Microsoft.compute resource provider get sent to Microsoft Compute before the deployment job gets started. Then Compute takes a look and says, okay, let me check out the configuration for all of these resources and check for any errors that they could probably validate before runtime. So stuff like OS names. If someone inputs an OS name of an OS that doesn't exist, that's an error that should be caught in pre-flight. And we're actively working with all Azure Resource Provider to improve the coverage of errors that we capture in pre-flight. The reason why this is so powerful is, like right now, for example, if you're just deploying a single resource, you could probably wait the deployment time with whatever it takes for that resource to let that error show up in deployment time. But if you have 200 resources in a template, and the very, very last resource that you have is the one with the error, let's say, for example, a storage account, then it'll be super painful to find out after waiting 15, 20 minutes for the deployment to finish. All other 199 resources succeed, but that storage account at the end shows you an error saying, oh, the storage account name needs to be unique globally, and it has to be between 2 and 24 characters. So right now with pre-flight, if you submit that deployment, it's going to return you that error almost instantaneously. So pre-flight is meant to finish under a minute, which is very powerful because then you're not wasting time waiting for these deployments to give you an error and guide you towards the correct state you want your resource to be in. So that, amongst others, as well as day zero support, are one of the most important reasons to be using ARM. Enough of the why and the what. Let's actually talk about what this module is going to cover today. So, Chris, walk us through what we're going to learn today.
Thank you, Angel. So what we will be covering initially is how we could be controlling the deployment order by us talking about a concept such as a dependency. That means that you were alluding to the fact that what if I have a number of resources, I want them deployed, and suddenly I have resources that are actually dependent on one another. There are situations where it is important to be able to specify that that is the case. Why you need that is because you want these dependencies to be deployed in a certain way so you can ensure that that first dependency does actually exist. Secondly, we'll talk about how you can manage secrets. And the reason why you want to manage secrets in the context of an ARM template is the fact that you don't ever want to put a secret inside of a text file because you're likely to put this in code revision like GitHub, and anyone with read access will be able to see what that secret is. So that's an unsafe behavior. For that reason, we'll introduce you to Azure Key Vault and how you could be using Key Vault with ARM templates and thereby managing secrets in a fairly good way. Thirdly, we'll have a look at how you could be using conditional logic with your ARM templates. And conditional logic in this case will mean, should I be deploying this resource or not? Lastly, we'll talk about how we could be creating multiple resource instances using something called the copy element. And one of the usage areas, probably the best one, is to clean up your template. I believe Angel might have some information for us also with some other great use cases on that. But more on that later. Can you tell us maybe about the next unit, Angel?
Yeah, let's just dive right in. So the first off, we're going to start with how to control that deployment order by specifying those dependencies. So as Chris mentioned, what we're going to do is see there's some resources where something needs to exist before something else can get deployed. That's the essence of setting dependencies on ARM templates. There's also a concept of nesting, when you can have a resource that's nested. The JSON of that resource is nested within the JSON of the other parent resource in this case. So, Chris, in summary here, this is what this would look like in JSON, correct? Can you walk us through what we're seeing here?
For sure, thank you. So what we're looking at here is our resources element, and we can see it's an array, so it has a number of resources. For this example, it has one. The important part here is that we're looking at this resources nesting. So we're looking at this resource element within a resource. Why this is interesting is that it takes up the case of we actually need to be explicit when it comes to saying, hey, I'm inside of this template in a nested way, so I actually need to tell ARM about me being a child and me depending on a parent to first exist. So what we're doing with this depends on construct is to set up this dependency. We're saying I rely on this parent resource. And as you can see, we are doing like a depends on based on the parent name. Now, this might not be the best practice, but it's a working one. We'll soon look at a more good practice way of setting up this dependency, but we're looking at two things, just to reiterate. One, setting up the dependency, and secondly, we're looking at nesting, where we do need to be explicit, even then.
I see. And then, so if we don't have them nested, you could still set these dependencies. And you mentioned the depends on construct is what we would use for that. So the depends on construct, as you can see, it's a key value pair where within the depends on array, you can specify the name of that resource that needs to exist first. So let's take a look at an example with a little bit more detail so we can see this in practice. So right now, what you see here is the JSON for a network interface resource. And this network interface resource depends on a lot of stuff. So it needs a network security group, it needs a virtual network, and it needs a public IP address resource to exist before the network interface resource can get deployed. And I see all of these are being specified here, but not with the name, Chris. So you mentioned at the very beginning of this talk that we're going to be expressing the configuration of these resources using simple text files, but I'm seeing more than just simple text files here. It looks like ARM itself is a language, and the resource ID to me looks like a function. Can you quickly explain what it's doing there?
Yeah, thank you. You're proving exactly the point we're trying to prove, which is that ARM is more than just dead text. It has a lot of functionality, and what we're looking at here is something called resource ID, which is also named a template function. There are a ton of different template functions that makes these things really easy for you. So what it does is to look up the unique ID. And the reason why we're looking up a ID instead of a name that we just mentioned is that an ID can be guaranteed to be unique, whereas names can actually collide. So what we're giving this resource ID function is two things. One is the base name, if you will. For example, every resource that's called network security group something starts in the same way, and the same principle with virtual networks and so on. The second argument we're giving it is a parameter input. So that's you inputting something on the console. What happens in this process is that it resolves. This one resolves in runtime to be this unique ID that you don't know the value of yet. So this is why it's so handy. The template function does all the heavy lifting, and you end up getting this dependency specified that's a parent and a child and a unique ID.
Awesome.
So yeah, back to you.
Thanks, Chris. So in summary, folks, we got the network interface. It's got an NSG that depends on it. It's got a VNet that depends on it, and it's got a public IP address that depends on it. And all of these are specified using the resource ID function. And with the parameters and variables function, you're also setting up your template, your ARM template, to be reusable. So for example, Chris did all the hard work of setting this up. And I want to have a similar setup, but in a different region, in a different subscription. I can ask Chris, hey, can you share that template with me? And it's already parameterized, so all I have to do is deploy it and add the specific names of what I want to use. So that's another big power of infrastructure as code. So this is great, but I want to see this in practice, and I'm a very visual person. So Chris, can you help us out with a demo, please?
Of course. Let's go. Let's share my screen here quickly.
Yep. As you do that, I just want to remind everyone, please ask questions in the chat. I'm sure our subject matter experts are taking good care of you all. If anything comes up, please just feel free to type it away. Don't be shy.
You see my screen, right, Angel?
I do not see your screen yet.
Do not see my screen. My bad. How about now?
Yep, we're with you.
Perfect. Hope this font size is good for you. Otherwise, just drop a comment, but it should be zoomed in. What we're looking at here is, first off, we're looking at the learned path, which is called Deploy and Manage Resources in Azure. I don't know if you said this in the beginning, but this is actually a path with 6 different parts in it. And what we're going through today is the last part. So if you haven't seen any ARM before, you're in for a ride. You got 5 other Learn modules to learn from, and I definitely encourage you to go there. I have clicked myself into the last Learn module, the one called Manage Complex Cloud Deployments. What we're looking at here is, first off, a sandbox. You mentioned in the beginning, Angel, that the sandbox was used so you didn't have to spend your own credits, which is an important thing to emphasize. So anything with Azure should ideally have this sandbox that allows you to freely test that service, so you don't spend any money. I believe I said in the beginning of the presentation that you could use either PowerShell or Azure CLI. I believe there's a feature parity here, and you can just switch between the two. If you're a PowerShell person, you will see how these commands will become PowerShell. If you're an Azure CLI person, it will just switch those commands so it's all Azure CLI through and through. In all of the exercises today, we will be using Azure CLI. So if that's what you're using, you're in for a ride. One of the first things you need to do if you were to do this by yourself is to open up an editor. In this case, we've opened up Visual Studio Code, and you need to sign in to Azure. Make sure first that you have clicked to activate the sandbox, and I think you need to click one more time to make sure that the sandbox has all the needed permissions. But yeah, right after that, right after the sandbox is set up, you need to log on to Azure. Once you do this, it will start open a tab in your browser where you're asked to select your account. If you got more than one, select the one that you want to use. It doesn't really matter for this exercise which one, because we're doing this next, which is to do an account set command. And this is us setting the the account of the sandbox. And this account is called the concierge subscription. To make sure that this shows up nicely, make sure to run this command first so it clears out any cache. Once you've run this command, then you can go back to setting this. Now you've done part 1 of 2 when it comes to setting up the sandbox, which means you've selected your subscription, but you want to do one thing more. And this is not a must-have step, but for these commands to work out properly, you need to be setting the default resource group. And when I say it's not a must, what I mean is some of these commands are going to take a resource group as a parameter, but by the fact that you set a default resource group, you don't have to specify that in the command. So this will save you some typing. So once you hit the AC configure with the resource group name, everything will be good. One thing worth mentioning is that as soon as you activate the sandbox here, a lot of these values will be pre-populated. So this resource group name will resolve to the actual resource group name, what it's called. So you can definitely trust what you're looking at here, given that you have activated the sandbox. You mentioned a few things already, Angel, what different constructs exist inside of a virtual machine. There's more than one. There's more than just the resource itself. It relies on things such as a storage account, a public IP address, so you can reach it, network security groups, and then some other constructs. To do this exercise, you need to be grabbing the template off of one of these URLs. Depending on if you have wget on your machine or curl, you can easily fetch it like so. Once you've done that, you can run a deployment command like so, AC deployment group create, and then you use Azure deploy JSON as an argument. And how come I can do that? Well, it's the fact that I have already run this command prior, which means that it has downloaded the Azure deploy JSON file for me. I just wanted to show you this file quickly. It has a ton of parameters when it comes to setting up a VM. Don't worry, we don't need to use all of the param and set the values of those, but we can only be setting up the admin user and its password, and we can rely on defaults for the rest. But I just wanted to show you quickly the resources again, the thing that Angel showed you in the slides. And here you have the network interfaces. You have the depends on construct that's already done for you. So I just want to emphasize that someone has already pre-prepped this template and set up the thing that relies on each other, so we can guarantee that everything will run smoothly once we deploy this. Now, once we run this deployment, it will take a few minutes for it to finish. One thing I want to highlight is the fact, what I said before, we don't need to specify all of the params, but we do need to specify the admin username, the name for the VM, and a password. As you can see, we're specifying the password in a parameter and not in the file. It's somewhat more secure than, well, it's a lot more secure than specifying it inside of the ARM template, but we can do better, and we will see how we can do that better in the next exercise using Azure Key Vault. Now, once we have deployed everything, one thing we want to do is to verify that deployment has been created. So we will be running this command for that, AC deployment group list, and we end up getting a table back. So once we get this table back, we see the name of our deploy, and also the resource group, which we have set up by default, and we should see succeeded. Last thing we want to do, or one of the last things, is to make sure that we can connect to the virtual machine. A simple way to do that is to make sure that we get the SSH command. So by running this command here, AC deployment group show, it will spit out the SSH command with the correct values here. So what this consists of is the SSH command itself, the user at a certain domain. Once you do that, you need to specify the password, because that's the next thing it's actually going to ask you for. So if you remember the password you set up in the beginning, just to remind you, once you're prompted for the password, input this password, insecure password 123 exclamation, and it should connect to your virtual machine. At that point, you can hit hostname as a command inside of the virtual machine, and it should tell you the hostname back, which is VM1. Lastly, you can just exit the VM because now you're done with the exercise. Congrats, you have been able to deploy a virtual machine that is using depends on. Isn't that amazing? Angel, I'm going to leave this one back to you so you can tell them all about Key Vault.
Awesome. Thanks, Chris. So I did notice the insecure password, and I agree with you. That's probably not the best practice. So you did mention that it's being parameterized, which is a bit better. And just to clarify and reiterate there, the parameter itself wasn't hard coded in the template. That's a huge no-no. Never hard code passwords into the infrastructure as code file, the ARM template JSON. The parameterization of it, it's better because you don't have it hard coded there, but still we can do a lot better, and that's what we're going to cover in this next section. So managing secrets in your ARM template by reading from Key Vault.
Do we have time for a question, Angel?
Sure, go for it.
Okay, so here from Douglas, he's saying, hello from Central Illinois. I have a question about this what if validation scenario. I found that there are quite a few scenarios where the deployment process actually fails, but the validation routes don't actually tell you if it fails unless you actually attempt to execute the deployment. This might be related to the pre-flight comment that was just mentioned. Do you have any comments on that one?
Yeah, correct. So when you attempt to deploy, that's when pre-flight is called, essentially. So that deployment gets sent to a pre-flight. Pre-flight breaks it across all the different Azure services. The different Azure services reply to pre-flight saying, this is good, or wait, there's an error in this one. And it effectively short circuits the deployment job for ever even starting. So that's what the flow of that is. Right now, we're actively working with all of the different resource providers to improve the coverage of errors that they're doing in pre-flight. There's a lot of validation errors that they're doing in their deployment API. But right now, to kind of migrate those and see which of those makes sense for us to do in the validation time rather than the runtime of the deployment is one of our ongoing efforts right now. So over time, the number of errors that we catch in pre-flight will just continue to improve.
How about one more question? Is an ARM template idempotent, i.e. can you deploy a template many times and achieve the identical result?
Yes. You want to take that one, Chris?
I understand, from my understanding, you may correct me here, I understand it that if you deploy the same template over and over, you have changed nothing, it will actually leave your resource as is. But if there are any changes in your template, some kind of property changes, it will actually deploy those changes to ensure that it's all up to date. Is that correct?
Correct. And the key here is to identify what deployment mode you're using. And the folks in the chat can clarify a bit better, but there's essentially two modes. You have complete mode and incremental mode. Most commonly, people will be using incremental mode to deploy, and what happens there is what Chris just described. If there's any change in the template, that change is what gets updated on the existing resource. In complete mode, for example, if you remove a resource from your template, then that resource effectively gets removed as well in the state of Azure. Whereas in incremental mode, that wouldn't happen. These are great questions. Definitely keep them coming. For the sake of time, I'm just going to keep running through this, but please continue to ask these in the chat, and the team will do its best to help everyone out. So to keep up the pace, keep up the momentum, let's move on to how to manage the secrets in an ARM template by using Key Vault. So as we chatted about before the questions, there's a lot of passwords going around when we're dealing with applications, when we're dealing with actual users, etc. And we want to make sure we are passing those passwords around effectively and securely. So what we're going to introduce is the Azure Cloud Service called Key Vault to how do we hard code rather than hard coding, how do we encrypt these passwords within Key Vault and reference it from within this Key Vault resource? So let's dive right into that. Chris, can you talk us through a little bit of the main features of Key Vault that are very important to us dealing with ARM templates?
For sure. So for those of you that doesn't know anything about Key Vault, here's a recap. Key Vault enables you to store your secrets in a safe way. They are encrypted. I believe there are many tiers, so you can really up the security level, but definitely the base level is good. Azure Key Vault in the context of an ARM template means that we're going to be able to read from this Key Vault in deployment time, which is very important. So by actually setting a setting or enabling a setting in the Key Vault, it can actually be open to be read from. One of the important things, though, is to ensure that we have that specific access so we can actually read from it because but also that the Key Vault is open to be read from. And what that enables us to do is to keep all secrets outside of the template and instead keep them in the Key Vault as they should.
I see. So essentially what you're saying is the Key Vault allows us to store all of these passwords and secrets within the Key Vault resource, and we can just reference it from within the template. But before doing that referencing step, there are some switches we need to enable within the Key Vault resource. Did I get that right?
Yeah, correct.
Awesome. Cool. All right, then let's take a look at an example, kind of explore in more detail. So this is what we just ran, the deployment command to go and submit the Azure deploy JSON for creating the VM. And the parameters that we passed in was the username, the name of the VM, and the password that is obviously an insecure password. So as we can see, even though this is parameterized, this is definitely not something we want to be doing. So in turn, rather than using the parameter, so what we have down here is the actual admin password being passed in as a parameter. How can we switch this section here within our virtual machine ARM template code to reference a Key Vault instead? And let's take a look at how we can do that a bit better. So we talked about the concept of referencing something from a Key Vault. So essentially what we're going to be doing is we take, we can call it whatever we want. So let's say, for example, we call it my password. Within this object, we're going to actually make a reference to the Key Vault. And in order to achieve this, all we need to do is pass in the ID of the Key Vault. So this is something we would be able to find through any of the clients or in the Azure portal after having created it and enabled the flag that allows us to read from the Key Vault. And then we give it the secret name that we're referring to, not the actual secret, just the secret name. So instead of using the my password parameter, we're going to use the my password reference to the key vault. And it's exactly what we would pass into here. It would still appear as a parameter, but rather than it being something that we have to input in on deployment time, what ARM does is it says, okay, we got my password. What is my password? Oh, my password is actually a reference to a key vault. Let me go resolve this and get this value and input it into this section of the ARM template during runtime when it's deployed. So this is great. But again, let's go to the visual part. That's how we learn better. So Chris, can you run us through a quick demo of how do we manage these secrets in ARM?
For sure. Let me just switch screens here. Okay, we're back in our exercise environment. You can see my screen, right?
Yep.
Okay, so I've clicked back to the entire module if you want to see what that looks like, and you can peruse these after this presentation or whenever you feel like it. So far, we've done this one, control deployment order of resources. Hel has been covering how to manage secrets. This is the conceptual part. And now we go into managing secrets. And this one starts by looking for an active sandbox. Had I clicked this sandbox, we could have used the same one, and all of our setup when it comes to using the sandbox account and using the sandbox default resource group, it would have been kept with you. So it's a very good idea to do this learn module from start to finish. We keep working with Azure CLI because, yeah, we don't want to shift context too much. One thing we do early on is to set a name for the key vault. We can be using this random variable that helps us to name things. We might have a prefix that's company specific or some good name. Only you know what this prefix might be, but it's a good idea of using a construct such as the random one, because let's face it, naming is hard, and you don't want to be creating what am I going to say, virtual machine 1, 2, 3, 4, 5. You probably want to have a better name, so make sure the prefix is a good one. First thing we're going to do, because we're creating this KV name parameter, is to create a key vault. So we use this randomized name and we set this switch, which is very important. We set enabled for template deployment true. And by doing that, we open the key vault up so it can be involved in this process. It's worth pointing out that when you set up a key vault like this, you have different policies that are created from scratch. So if you are the creator of the key vault, you will be set as the creator policy-wise, so you don't have a problem reading from the key vault. If a colleague of yours have been creating the key vault, you can be added as a contributor and is still able to read from the key vault. So it's worth mentioning as you peruse through this learn module or through the docs, there is a policy. I believe there's also an RBAC solution that's coming, where you can have more fine-grained control. I think it's in the preview, and Hel can probably tell me after this exercise if that is the case. Right, so we assume that we have access to the key vault by us creating the key vault, but also because we do enabled for template deployment. At this point, this will take a minute or so, and it will create the key vault for us. Once we've done that, we can create this secret. Same key vault. This time around, we call it VM password. And yeah, we can use this value, or you can add some other value. If you change this value, make sure that it reflects as you try to connect towards the VM later in this exercise. One thing that's worth pointing out, Angel, I believe you were showing us two different files when you showed us on the slide. The top one being a parameter file. So instead of specifying a lot of parameter on your console, you have a parameter file which is easier to maintain, and it's something that you can maybe put in version control as well. It shouldn't have any secret values, remember. It's just what parameters and maybe some useful defaults. One thing you want to do is to call AC key vault show. At this point, you're able to see an output, which is your key vault ID, because this, if you remember what Angel was saying, this is an important component as you point out the exact ID for the key vault. So during deployment, it understands what key vault to go towards. Once you do this command, you will be given an output similar to this, which is the unique ID. Now, we need to be creating this Azure deploy parameters.json file, which is our parameter file. So we go into here, and what we need to do is we need to change this value, this ID value here from empty string to that ID that is the key vault ID. Once we've done that, we set the secret to VM password, and by us just doing these small 2 changes, it will actually know what secret to go towards, what key vault, and in runtime, it will be able to resolve the value of the password, or the value of the secret in this case. Next up, it is about deploying the Linux VM. So we're going to use the same template because reuse, right? Because it's so parameterized, we can reuse the same template. And all we need to do is, instead of creating this admin account via parameters, you remember key and value, we use this parameter file instead. And we also need to change the DNS label prefix, because now we will have 2 different virtual machines up and running, whereas the second one that we are about to deploy will be the one that we're going to try to connect towards. So remember that we use a parameter file that leads us to the key vault, so the key vault knows to give us that secret value. Once we've deployed this with the AC deployment group create command, we can call this show command. Now this one actually runs the command. So instead of just outputting the SSH command, what we should be copy pasting, we can instead just rely on this to connect towards our virtual machine. And once it does that, we enter the password and we should be logged in. So once we're logged in, again, we can hit the host name. Once we hit the host name, it should answer us back with VM2, which is our second virtual machine. And this virtual machine has now been created thanks to the fact that it, during the deployment process, read from the Azure Key Vault. And now, Angel, back to you.
Awesome. Thanks for that, Chris. Let me take over again. All right. So as we just saw, we learned a little bit about how we can use the Key Vault resource to manage these secrets. So rather than using plain text, let's actually store these somewhere that is secure, they're encrypted, and then we're only referencing them. So on deployment time is when the secret's actually read by the ARM template, not by anyone. So now let's move on to how we can add conditional logic to our template. So if something happens, what can get deployed? What are we going to do? So this is super important because sometimes when you're deploying stuff, you might want to be deploying it optionally under certain conditions. So for example, if this resource exists, then let's actually kick off the deployment of these other things. And those resources might not necessarily depend on each other. So that this is the tail end of when that relationship doesn't exist. What else can I use to conditionally deploy a resource? And more importantly, branching logic. So sometimes you might have an ARM template that takes care of a lot of stuff, but you only want to deploy certain sections of it. So for example, you might have your different development stages spread across development, pre-production, and production. And you might have a flag in your template that says development. So if you submit that template for deployment with the parameter flag of development, then you can have a condition in that template that specifies, okay, this is the development stage. We're only going to deploy the development section of this ARM template. But to kind of look through this in a little bit more detail, Chris, kind of building on top of that example, can you tell me more about, if we continue on with Tailwind Traders, that organization, why would they use this condition construct for that scenario of deploying different stages?
That's a really good question. As we've seen so far with ARM templates, we can use parameters to make them really flexible, but we can take it another level by using this condition element. What it allows us to do is actually to deploy it, for example, in different environments. So imagine that you can deploy it in staging, pre-production, production, development. Because of that, and by using this condition, you can make sure that when you deploy something, it's reusable in different environments. So condition sets us up so that we can verify, so we can try to meet a condition. If it's met, we will try to deploy this resource. If it's not met, it will skip it. So yeah, awesome. Take it away, Angel.
And so before I continue on, I want to ask you, how did these get evaluated? So it looks like it's simple, true or false, but there might be something else on top of that.
Great question again. Yes, you can actually start by passing true or false through the parameters, but by using another template function called equals, we can actually measure the value or compare the value that we get in as a parameter value towards another custom value. So for example, we can see if someone sends through stage or staging, we can say equal, does my parameter value equal staging? So by using condition plus the equal statement, we can actually leverage more template functionality or template functions and make sure that it's very flexible, so it's readable and makes sense to you.
I see. So the example that I was alluding to at the beginning is actually using expression evaluation, not just simple true or false.
Correct.
Awesome. So the simple or true or false would just look exactly like this. So if we have a parameter where we want to say deploy account, then we can have a default value of true set to it, meaning yes, deploy this. But if we want to pass into the deploy account false, meaning we don't want to deploy that specific account, it can be a storage account, it can be any other resource, then that's a parameter that I would pass in as I'm submitting the deployment. And the expression evaluation, as we talked about, is making use of a function called the equals function, where it takes in two arguments and it makes a comparison to a custom value that you provide, in this case, new. And then whatever parameter gets passed in, it compares it to that. If it matches, then it's true. The condition will evaluate to true because it's equal. If it's not equal, then the condition would evaluate to false. So let's take a look at a more detailed example for this. And Chris, I know you mentioned that the tailwind traders organization example that we have in the learn path, they might have a development phase, a staging phase, and a production phase. So right here, what they would do in their ARM template is have a parameter where the environment is the actual parameter name, and it's spread across the default value, having a default value of development, but there's more allowed values to this. Then in the actual JSON that they're using, what they would have is a call out saying the condition for this resource to get deployed needs to evaluate this equals first. And what it's happening is this equals is going to say, okay, parameters, environment, production. Production is an allowed value. Okay, this looks good. This should deploy. If something else were to be passed in, let's say, for example, pre-production, it's not a part of this list. So in that case, it wouldn't deploy. Is that correct, Chris?
Yeah, exactly. So you would actually get some kind of validation error if you were to pass a string, let's say pre-prod, that is not part of that allowed values list. Worth mentioning also is that you have a default value of dev. So even if you don't specify the parameter, it will default to dev. So your deployment will work anyway. It's only if you specify a value that it doesn't recognize in that list of allowed values.
And I could use this as much as I want throughout the template. Like I could have a condition for each resource, right?
Yeah, pretty much.
Awesome. So this definitely gives me a lot of flexibility as to not just making the template reusable with parameters, but reusable with conditions, and using parameters and conditions together to make that flexibility exponentiate more and more. Awesome. So this is great. Let's switch on to a demo. So Chris, can you walk us through what this would look like in practice?
For sure. Let me just switch to my screen here. There we go. And we needed to navigate back. So we go back to this ARM template and we have done this one. So we have learned about controlling deployment order. We've learned how to make things safe by using the key vault. And thirdly, we will now look at conditional logic. As before, if you've started this ARM template in one go, you still have time left on the sandbox. Definitely use that because you have set up the account, you've set up the default resource group, and do select the dialect that you want to be using to carry this out. Again, PowerShell and Azure CLI has feature parity, so it really doesn't matter. Just to reiterate what you were saying before, Angel, we do have different environments in this scenario. So we imagine that we want to deploy the same template in dev and to staging and to production, but there is a difference and we want it to behave differently depending on what environment that we target. So yeah, here's the scenario. As you move from dev to production, you require additional infrastructure, which makes a lot of sense. We might need to have some extra power when we're out there. So for that reason, we want to add this condition statement just to make sure that, oh, okay, we're inside of production, so we need that extra power. What we do is to create an ARM template that has two different parameters. One is the environment that we want to specify, and the other one is a name for storage account, because the storage account is what we're about to deploy in this case. You might have another type of resource, but we want to focus on understanding the logic of this construct. So as we were saying before, we have three different allowed values, dev, staging, and production. We would put those inside of the allowed values part as part of the parameter. We also want to make sure that the condition is defined as follows. We only want to deploy this specific resource when we are inside of production. So imagine that you're looking at a very long ARM template. In this case, it's a bit shortened, but you might have 10, 15, 100 different resources, and you want to just specify, okay, first off, I want to make sure that my parameter has set up all the allowed values. So I do that. If you got pre-prod, this is the place to add it if you want to add more allowed values. Also, a default value is nice if you have a fallback. So if you're inside of dev, you want to be fast, right? You just want to keep on maybe working on the code or working on other templates. So you don't want to think too much in dev, but you do want to think and stop in production. So for that reason, we make sure that you actually have to specify production, because then something exciting happens. Now, as for the resource, we set it up with this condition element, and this condition element leverages the template functionality equals. So we can now compare our parameter value, the environment one, and see if you are production, that means I will evaluate to true, which also means that this resource will be deployed. And that's how it's set up. So it's just so you don't have to pass in true or false, because from a business sense, what does even true or false means? It makes a lot more sense for you to pass in, production or staging or dev than to pass in a true. So this is very nice. I really like this equals function. Now, to provision the environment, one of the first things we need to do is to set up a nice storage account name. As I mentioned before, naming is a bit tricky, so we need help. We want to have some nice prefix. Because we work for Tailwind Traders here, we use that as prefix. In your case, you would be using some company prefix. We use the fact that this random construct exists. You don't have to use it, but it's easier that way to guarantee that you have a unique name, but still it kind of complies to some kind of business logic. After that, you want to run your deployment. So you specify this condition JSON file that you have created with your resource and all the other logic and parameters. And as a parameter, you specify first the storage account. And lastly, you specify the environment dev. Now, we could have skipped that. We could actually have skipped that, because if we reiterate here, we see that the parameters actually defaults to dev. So we could have just said, oh, okay, I want to be a lazy dev today, so I'm just going to omit this completely. That would have worked. But you wouldn't have gotten the storage account, right? Because remember, the logic here was to say, if I'm actually in production, then I get a resource. So to verify our deployment, we can check whether the storage account name is actually busy. Now remember, because we're calling it with dev, nothing should have happened, so it should have been free. So you should expect to see this message back, which says name available true, which means nothing has been deployed. your storage account name can be freely used. You want to change things, right? So now we put on the thinker hat. So instead of being in development, we are in production. So, okay, this actually means something. So instead of specifying dev or nothing, we actively remind ourselves that, oh, we have some deployment logic here if we specify in production. So now we need to think, now we need to breathe, because it's for real, right? But as with every kind of process that where we deploy often, even if there's a mistake, you can undo it pretty quickly. That's part of the whole IAC, the CI/CD, idea to fail fast, deploy often, and fix things often. So here we change the deployment. We run it again with the same template file, but this time around, instead of specifying nothing, we specify environment equals production. So now it will hit this logic, and this logic will say, oh, okay, I actually have a resource to deploy. To verify this, we do the same check for the name to see, are you busy? Or, what we're saying is, are you taken? So it should say name available false. This name is already taken. And now you know that you have run it in production, you have got your resource up there in the cloud, and everything works as it should. If this is some other type of resource that powers up your production environment, great stuff. You've done your job and you earn a coffee. Now, back to you, Angel, and tell us what more exciting constructs we have out there.
Awesome. Thanks, Chris. That was great. And I will take you up on that coffee that I just earned by learning through all of that. So the last but not least, we're going to talk about how to eliminate those redundancies in ARM template code by using the copy element, the copy construct. And for the sake of time, we're going to run through these a little bit faster because we want to make sure we can take in as many questions from you folks towards the end. So let's dive right in. So what is the copy construct? In essence, and I'm oversimplifying this by a lot, assume you have different blocks of different resources within your ARM template code that are effectively doing the same thing. You're just probably changing the name of it or maybe 2 or 3 properties. So what's going to happen here is assume I'm creating the same Linux VM 10 different times, and all I'm changing is the name for that thing. So rather than having an ARM template that's bigger than it should be, and I want to reduce the number of lines of code that I'm using, instead of having all of these blocks one on top of each other, I could just have one block with the copy construct that what it does is it ends up saying, okay, Azure Resource Manager gets the ARM template. It takes a look at the configuration for this VM, and it says, okay, you want a Linux VM, you want this many data disks in it, this. Oh, and you want how many copies? Okay, 10 copies. Let me go and get that done. And ARM takes care of all of that for you. So let's continue on and let's actually dive right into this demo, Chris.
Fantastic, Angel. It's the last exercise of this presentation, so I hope you've been awake so far. If not, wake up, right? Oh, need to select my screen as well, and there we go. Now, quickly up here, make sure we get through the entire module. Hopefully, you've seen some really valuable situations already with a key vault, with a VM and the copy element. And now for our last exercise, let's talk about how we can reduce repetition, because that is one really great business case, as you were alluding to, Angel, when you showed I don't have to type things 3 times. If they're that similar, why can't I just type it 1 time and say, hey, do this 3 times? So this is some content that you could be adding to your existing copy.json file that we used in the last exercise. So what we're looking at here is a way to specify our storage account and storage account name. So we see here that we have a parameter called storage count. This is how many times we want something to be repeated, which is kind of good to know that we have a parameter for that. So if you want 100 storage accounts, by all means, do that. I'm not sure how long that's going to take to deploy, but I believe deployment happens in parallel, so it should be fairly fast still. So looking at this template, how it uses this, we can see that the copy construct is here. And we can see that all of that repetitious resource code isn't there anymore because we specify the resource once, we specify a name for the storage, and we call it storage copy, and we have the storage count that tells us how many times we will be repeating this. So that's really all there is to it. Of course, you could be referring to indexes, and I think Angel will mention that, but there's also a way to control this. For example, if you want to know, I'm deploying the third one, and in the third one, I want to do something. So there's also an index that we could be referring to. Now, to deploy this template, we set up a storage account name, and we say storage account 2, which means now that our template will be repeating this twice and provision the storage accounts we need. So to verify the deployment after we have deployed it with the storage account name and the storage account itself, we can just verify by saying, hey, give me the IDs of the output resources. And so yeah, that's exactly what we're doing. We target a specific deployment and out comes 2 IDs, which is exactly what we said, right? So we want this resource to be in 2 copies, which is exactly what we're getting back. That's perfect. And we can also see that we got 3 in total. So if you remember what I said in the beginning, we want to know how many additional, right? So we get the base name, and 2, we get this one and that one. So that's awesome. I'm going to leave this back to you, Angel, to reiterate over this construct and how it can be used in maybe some other cases.
Awesome, Chris. Thanks for that. It was quick enough. Before kind of reiterating that, I want to take a few questions in the chat very quickly and kind of warm us up for the lightning round of questions. So first off, we got if we're able to use multiple conditions. Yes, you can use conditions in each resource. There's no limit to where you can use these conditions. So there's actually a lot of interesting solutions around this. I'd be interested to learn more about what scenario you're looking to use multiple conditions for. So if possible, drop that in the chat, and the team and Chris and I can do our best to help. Second, regarding Bicep. So when are we going to see the Learn modules and learning paths for Bicep? So for those of you who don't know, Azure Bicep is a new project where it is a simpler language that's native infrastructure as code as well. It's built on top of the ARM template language, and it essentially enables some new programming features that aim to really simplify your experience. So with regards to a learning path for that is actually a discussion that's ongoing, and we're hoping to get it planned and out as soon as possible. But like that comment, if everyone is very excited about seeing a learn path for Bicep, that'll also help us reprioritize the work that we're taking on internally. Awesome. So
there's one.
right.
Yeah, please
go ahead.
Yeah, so I saw there was one interesting question there that talked about templates being referred to by URL. I think the answer to that question is that we are covering that earlier in the ARM path. So I think we're right. So yep. I think we have an earlier learn module that goes into that case. So this is only part 6. We needed to make it small and focused. So definitely go back into that path and have a look, because I believe it's one of the first 3 ones that covers it.
Yeah, we encourage you to dive right into aka.ms/ARM template learn as well for the full list of the learn path. But if you go to the one for this specific one, it's very easy to find. So ak.ms/LRN251. But moving on to continue, and I love that we're getting a lot of questions, but Chris and I have some questions for you, so we're going to quiz you guys to actually see who's been paying attention. So let's dive right into some knowledge check, and that way we'll know exactly who's been slacking and not paying attention. Just joking, obviously. So the first question that we got is, how do you create a dependency between two or more resources. And Chris, can you give me a summary of what we learned in that section so folks can have a quick refresher in order to answer this one?
For sure. Thank you, Angel. We learned that the depends on construct was what we needed to use to make sure that two things are interconnected. So what we do in this depends on construct is to point out the parent or parents, is plural, right? So the depends on points to an array. Preferably what you're pointing to is an array of IDs. It works with names as long as there's not a name collision, but definitely make sure to resolve them to IDs to be on the safe side of things.
I see it. And by name collision, you're referring to there sometimes might be multiple resources that have the same name, essentially.
Yeah, exactly. That do happen, but they definitely don't get the same ID. So there's more of a guarantee there.
Awesome. Cool. Well, hopefully a lot of you have gotten a chance to answer. I'm going to probably wait 3 more seconds for more folks to get your answers in. So 3, 2, 1. And the answer is, as Chris mentioned, getting the depends on construct on a resource. And what we're doing here is we're telling Azure Resource Manager via an ARM template, this resource depends on this other resource, and that translates to ARM waiting for that other resource to exist before it attempts to deploy that resource where the dependency is declared. So let's move on to question 2. And let's give a little bit less hints this time around, Chris. So I still want you to give us a summary, but I want less hints. So what we talked about in the condition element in a nutshell.
Right. So in the condition element, it was an element where we could set it to true or false, and we could place it within a resource. And by putting it inside of a resource, we were able to enact logic. We could ensure that we could read from a parameter. So that parameter could either have the value true or false, or it could have any string value. But if it had any string value, we needed a helper function called equals to make sure that when we do the comparison to the parameter value, we would have to have as the second argument that string that we know to be correct. So essentially 2 ways of ensuring that that condition is being evaluated. Hopefully by now most of you have gotten your answers in, right? So
let's see. So it's to conditionally deploy the resource. So it evaluates the true or false, as Chris mentioned. Conditions can be used across the entire template. There's no restriction as to where, like no specific resource can only use conditions, and like you can use it in every resource. And you can evaluate expressions. So rather than just passing in true or false to deploy that resource and evaluate that condition, you can actually use the equals function to say, if this specific custom value gets passed in, evaluate that equals to true, and in turn evaluating the condition to true.
Yeah, so, just a quick comment there. I believe 82 in the chat. I believe 82% got that question correct. So that was awesome.
Awesome. It's good to see folks are paying attention. Makes us feel like we're doing a good job. So last question. I promise I didn't mean to give you a surprise test here. But the last question is, how do we get the current index in a copy iteration? And, we did speed through this last section, so you can give hints on this one, Chris, because we just wanted to speed through it so we could get to this and then get to some more of your questions. So let's kind of speed through this one as well.
For sure. So I did mention that we could refer to the index. It could be important for naming or executing some kind of logic to know exactly what resource we were on. I believe the ARM team has done some thought here, because naming is hard. So I believe the answer is probably something that has to do with the construct itself. Am I right? Index and the name of the construct would make out the function name that would resolve to an ID. So if you remember what the construct is called, you probably know what you're supposed to answer here, right? So the construct is called and what we're trying to get is an index.
Correct. So the answer for that one, as Chris mentioned, it's pretty much the copy index. So we've made it as simple as possible. So if you want to get the current index in a copy iteration, you use the copy index function. So what did we learn today? We've been talking for over an hour. It's been a lot of stuff. Let's go through a quick summary.
One. Sorry,
Go ahead.
I just want to quickly comment. We got 50% correct on that one. So yeah, it was our fault because we were rushing it. Otherwise, I think most of you would have gotten this one if we had highlighted it. But yeah, take it away.
No worries. And yeah, we wanted to speed through this. It's a lot of content, so thanks for sticking with us. As a summary, what did we learn today? So we learned a little bit about how can we specify dependencies to control the order of how resources get deployed. We learned best practices in managing secrets using Azure templates with the Azure Key Vault resource. We learned a little bit about how to conditionally control what gets deployed in a template by using the condition function in ARM templates. And lastly, we learned a little bit about how do we reduce redundant parts of our templates. How do we eliminate those and reduce the length of our template by using the copy construct? More importantly, the benefits of ARM, I want to reiterate those as well. So as Chris alluded to throughout this entire session, speed. Speed is the number one thing. So rather than having to repeat a lot of steps more manually by using the Azure portal or any other client, when you embed these all into an ARM template file, then you can make quick iterations on it and redeploy. And not just yourself, but different members of your organization. You can take this template that you already parameterized, you already spent the work in building it out, and share it across your organization. And furthermore, you get speed in the sense of failing fast with pre-flight. So by failing fast with pre-flight, what we mean again is ARM is designed to let you know, so it actually validates that resource as best as it can outside of runtime, and it gives you feedback on saying, hey, this actually, if I submit this for deployment right now, this is going to fail. So you need to fix something. And that validation API, you want to leverage it as much as possible. And you can only do that by using native infrastructure as code. So Azure native infrastructure as code right now would be ARM templates, as well as Bicep that we talked a little bit about. So that being said, the last thing is day zero support. So by day zero support, as soon as something new comes out, your organization is able to test this out that same day. As soon as Azure announced something new, you're able to codify it into your ARM templates and give it a shot. So this is super important for the fast pace the cloud is heading in. So lastly, these are some of the resources that we talked about today. The link to our Learn module, a little bit about Learn Live, which I'm going to talk about now. And towards the end, you're going to get an evaluation form for this session. So if you enjoyed it, think we did great, please give us some feedback. If you think there's some stuff that we can improve, please give us some feedback as well. Everything is very much appreciated. So before we all leave, so we want to talk about the Microsoft Ignite Cloud Skills Challenge. This challenge is running through March 30th, if I'm not mistaken. And what's going to happen here is Learn is not just somewhere you go and go through some modules and learn. You're actually getting XP points throughout all of this. So we've really gamified this experience. So our customers can actually show each other, hey, I have 10,000 XP points because I've gone through these many modules. And by going through these and joining today in the learning zone with the myignite.microsoft.com link/learning zone, you're able to become part of this skills challenge. For customers that go through it, what we're going to do is you're going to earn a free Microsoft certification exam. And Chris, I know you took this exam way before Learn even existed. So can you very quickly tell us the value that they're getting here?
Yeah, so taking any kind of exam is super good because you're able to verify that for you that you know things. As with all exams, it's important to also use them in the real world. So it's a great stepping stone towards being a professional. So this is a great start. Learn definitely have covered, I think, all or most of the Azure certificates. inside of Learn modules. So you will see gigantic paths with, I think, 20, 30, 40 modules. So you don't need to buy a course anywhere. You can actually learn everything right on Learn. So I'd really recommend going down that path.
And by going through the challenge, you can get a chance to earn the certification exam being paid for you, which is awesome. So we're at time. Thanks everyone for the time. Please check out Learn Live TV starting March 15. We're going to be covering a bunch of different topics here. Again, Angel Perez from the ARM deployments team, Chris Noring, one of our best cloud advocates out there. Thanks everybody for joining. Really appreciate it.
Thank you.